Vitaly has our last honorable mention all ready to go.
So this one is from Patricia Verrier from United Kingdom, and this submission is 140 characters exactly. And what this one does, it takes a photograph of our planet Earth taken from space and trying to actually make a sort of an oil painting of it or something that looks like that. When I look at this image, I immediately think about Van Gogh's Starry Night or Monet or any oil painting similar to that, like from impressionist era, you know. And basically how this is achieved, it's a very interesting mapping between the data that are called image and that can be easily accessed in Mathematica to the data format which is called graphic, which we can easily do in Mathematica. And for some non-dedicated users, probably it would be interesting to know what is the difference between graphics and image, because it's sort of a sound synonymous to each other. Like image, it's a representation of an object in terms of the pixels. And graphics, in this case, it's a specific graphic primitives like points, dots, that if you, for example, drag around like this, scale pretty well, and they don't lose the resolution. If you would do the same thing with the image, of course, it would lose the resolution. So to explain how it works, I have to explain you a few pieces of the code, and there are some very neat constructions here that I would like to go over here. So first of all, this code uses built-in astronomical data, which are stored in Mathematica, and takes image of Earth, real photographs, and does some sorts of a manipulation. The first operator that applies to it is called image data, and basically what it does, it extracts RGB channels from that image, and the next one would operate, for example, on rearranging them, because when you go from image space to graphics primitive space, you have to a little bit rearrange the data around. One of the most neat functions here that you probably don't see is called transpose. It's a little t, kind of like the power here, but it's not really the power. So the person used this technique to save some characters, and I would like to explain you how it works. Imagine that you have a simple matrix, right? In Mathematica, it's a list inside, two lists inside of list, and you have something like this. So this represents a matrix, which you can easily see in the matrix form. But this shortcut notation, what I'm going to do currently, I'm going to press escape, then I'm going to press TR and press escape again, and this creates that little letter here, T, and if I execute it right now, you see it's exchanged by the places of diagonal elements, 3 and 2, and this basically means that operator transpose was applied. And it's very neat trick, because otherwise you have to type the full function name, which is called transpose, and it's really a lot of characters. So this was one neat trick used in this code. And another one actually was using of the function which is called map index, that very convenient construct in Mathematica. I will briefly show you how it works. We all used to the construction which is called map. We use it pretty often. And here I construct a random matrix 3 by 3, and we see if you map a function q, you basically, at a level 2, you have to specify a level. You have this function applied to every element inside. But when you map index this function, you see that not only it's applied to every single element, it's also pick up the index of the element and feeds it inside the function as a second argument. And it was invaluable, a very neat construct for this specific piece of the code, because this is the way you see this graphic, the graphics here and the disk. So this was the way to understand where to place the disks instead of the pixel. Basically what we do, we extract information about the pixel, RGB colors mapped actually on the color information inside this data, but also we extract where the pixel is located in terms of its coordinate. Like, for example, this pixel is 20 and 30, we extract it, we feed it to the where this disk is supposed to be placed, and we get this interesting image. So I see that Patricia has a really intricate knowledge of our functional programming language and understands how she can manipulate this function and compactify the code to construct some sorts of artistic representation of this photograph.